Hello, this is Mr. Humbart here. For this video, I'll try to go through this assignment, Chapter 7, Section 1. So the first part is a major league pitcher pitching this baseball with a mass of .101 and this speed or velocity, in this case, of 35.1. We're going to use P equals mv, and solving this, we'll do .101 times 35.1, and we'll get 3.5451. There's probably more, but I just left them off. We only care about the first two decimals though, or it looks like 3, and our third one is that one. It's a 5, so we round that up. We get 3.55, exactly like shown here. So just calculator, and you should get your answer. Alright, so for number 2, this time we're given the momentum. We have this mass, and we have a momentum P, because kilograms times meters over second is momentum. We want this speed, or V, and to do that we have to set up our equation. P equals mv. We can use the triangle thing, or we can just plug in our values. P, M, V, we want V, so V equals P over M. Cover up the V, get that. Or we could plug in our values, 30 equals 11.1 times V, V equals 30 over 11.1. However you want to do that. So once I do that, I should get 2.701, and I only compare about 2, and that's a 1, so I drop that. I get 2.70, and that is meters over second, because it's a speed. Number 3. We have a car and a bike moving toward each other in opposite directions. So we're going to use we want total. So we use this equation, P total equals P1 plus P2. That means that each P has a separate momentum and a separate mass, or velocity and a separate mass. So this is M1 V1 plus M2 V2 if you want, or P1 plus P2. So each has a speed of 24, but they're going in the opposite directions. And their speeds are going to be velocity in this case, because the direction is going to matter. So, and it says the car is moving in the positive direction, so we'll say P1 is the car, and P2 is the bike. To do that, I'm going to say the car has this mass, 36 times positive 24, because it's going in that direction. The bike, though, has this mass, 86, and now it's negative 24 in that direction. Multiply these together and add them up. I should get 29,280 kilograms. Or no, kilograms times meters over second, because it's momentum. All right. So for this one, number 4, we have this time, we have this distance, we have this mass. In this case, this distance can be displacement, because we want the formula P equals mv, which v is of course m times displacement over time, which is the definition of velocity. So we'll plug in all our values, we get 57 times 321 over 9.01. Get an answer for that, I should get 2012.87 which I'm around because I want this to know decimal places, it looks like. There's that 0.8, so I can round that up to 2013. That's what I get. All right. Number 5 is a little complicated because we have to convert. So first I have to convert this entire thing, but let's figure out what we want first. We have this train. I don't care about these things. 1989, 7 kilometers long. I do care about how long it traveled and how long it took. And so it gives us the train's average momentum, P, and we want to know its mass. So using P equals mv, in the fact that we can use the triangle P, M, V. I want M, so that's P over V. I'm given P, but I don't have V. So I'm going to write it like this. So 8 is my P, 17, 4, 13, 406. Now, on the very bottom, we have to do something. We need a very long unit conversion to convert all this stuff. Because I have to make this meters over second to match. So 832 over 21.22 kilometers per hour. So on the bottom, just remember this is in the divisor. It's over this entire thing. I have to first convert this kilometers to meters. You'll find that when you look up kilometers, it's 1,000 meters. So I multiply it like this because I want to cancel the kilometers, like so. Now, I want to convert hours to seconds. And I know that 60 minutes are an hour, so 1 hour has to go up here to cancel. 60 minutes goes down there. And I also need to convert to 60 seconds on the bottom here. Like so. If I multiply all these out, I should get an answer of about 75052 698.21 kilograms. If I did all my math right, my calculators. That's a 0.21. I don't want any decimals, so there's my answer right there. All right, for number 6, we have a 0.09 kilogram baseball traveling to this right at this speed, or velocity, I mean. And we're going to assume right is positive. And the batter hits the ball back. We want the change in momentum of the baseball. So it's the same ball. We can say that change in P equals M times delta V. So the mass is the same. And we're going to say that 0.09 kilograms times, that's initially going 4.3, like so, to the right. Then finally, because we want V final minus V initial, is delta V. So 4.3 minus 4.86, because that's going in the opposite direction. And when I do that, I need to remember that I'm taking the absolute value of this. The negatives are going to cancel out nicely. So I'll get 0.9 meters over seconds equals 0.9, 4.86 plus 4.3. Add that up, I should get 0.8244, and I can only care about 2 decimals, so I drop these 2 because it's not a 5 in the third place. And I should get that answer, 0.82. For number 7, I have this soccer player with this mass, and this time around there's no mention of magnitude in the problem. Before it says magnitude, absolute value, right up there. This one doesn't have that. So for this problem, I have this mass of this guy, mass of that guy, and it's a total, so I add them. So P total equals P1 plus P2. We'll do this momentum, because momentum same times V, and we'll say that 2 is the soccer player number 2 and 1 is soccer player number 1. So this is soccer player, the total momentum is 2.8. We'll choose positive to be the right, because that's usually what we do. And we say that this can equal 40 kilograms, because that's the mass 1, times his speed to the right, plus 1.6, plus, this is his second player's mass, 39 kilograms. We don't know his speed, V. We do know this is 2.8 equaling 64. We use calculator, plus 39V. And at this point we can just solve this out. So whatever 2.8 minus 64 is, so we gotta subtract 64 to both sides. I get negative 61.2 equaling 39 V, and I divide 39 both sides. V is going to be negative 1.56769. There's more, but I cut it off because I don't care about that. So I only need 3 decimals to check. It's 2 decimal places, so I round to 2. That's 9, so I will get rid of that and bring that one up. So it's negative 1.57 meters over second. That's the speed of the second player. Okay, last problem. For this one, we have this ball falling downward. That's in grams though, it has to be in kilograms. So we divide that by 1,000 grams. The reason we do that is to convert kilograms. So we know that's what we have to do to cancel that. So 0.279 kilograms is our mass. So I did that without doing anything else. Now I know it's hitting the floor with this speed, 2.7, then rebounding upward with this speed. I'm going to say down is negative. This time I have this change in momentum magnitude. Okay, so for this, if I'm hitting the floor with this speed, I want delta P equals M times delta V. I'm going to do 0.279. If down is negative, V final minus V initial. That's what I'm wanting. So V final is going to be upward 1.9 minus V initial 2.7 7 going down. And then I multiply that together, or add that to this. Negative, negative, positive. So these two will make a positive number. So I add those. And I should get 0.279, 1.9 plus 2.7. Multiply that together, I'll get 1.2834. Looks like it. I want 2 decimals again, so there's a 3 here, the third decimal spot. Ignore all that, and that is my answer right there. And that's it. Have a good day.